Much of this lesson is pretty self-explanatory, so what I've done is I've written the notes for you guys to take a look at. I will highlight some of the important things, but I'm not to me, email me and I'll be happy to help you with that. But in any case, so we're going to do our statistics unit. Statistics is the science of collecting, organizing, and interpreting data. Statistics are the data that describe or summarize something. And in this show, there are 22 million viewers, but you know that you're not going to necessarily count 22 million people. You may be surprised to learn that the data is only representative of 5,000 homes. That is what we refer to as a sample, and so we'll discuss how this all works throughout our lesson. In the language of statistics, we see that Nielsen is interested in the population of all Americans. Doesn't matter gender, race, ethnicity, all Americans. And the characteristics of the population that they want to learn about is the number of people watching a television show. And so this is called a population parameter. So we're looking at a very, very small or specific piece of, all Americans, and that can be a bunch of different things. Nielsen cannot realistically study the entire population, so we look at a sample, which would be 5,000 homes. So we're going to break this down into different pieces. In this example, the population is all Americans. Okay. The population parameter is what we're interested in. Okay. So of these Americans, all the Americans, how many of them will watch each television show? So this is Americans watching a show. Okay, and then the sample would be 5,000 homes. Okay, and we'll talk about the sample statistics in a few moments. This is a pretty nice little map of everything we're going to discuss, so definitely look through this. Okay, so here we go. We're going to describe the population sample, population parameters, and sample statistics. Agricultural inspectors for Jefferson County measure the levels of residue from 3 common pesticides on 25 years of corn from each of 104 corn-producing farms. So the population would be all the ears of corn grown in the entire county. Okay, all the corn. The sample would be the 25 ears from each of the 104 farms. So that would be a total of 2,600 ears. The parameters, population parameters, are, well, what are we looking for out of this population? And that's specifically the average levels of residue from the 3 pesticides on all the corn, okay, all the corn in that population. So we look at all the corn in the county and then the average levels of residue. The sample statistics is the average residue on the ears of corn in the sample. Okay, so that's what we break it into. In order to gauge public opinion on the president's plan to contain Iran's nuclear program, the Pew Research Center surveyed 1,001 Americans by telephone. So the population is all Americans. The sample would be the 1,001 Americans that are being surveyed. The population parameters are going to be the opinions of all Americans, and the sample will be the opinions of the sample, which is the 1,001. So the population is basically everyone. The sample is what we are specifically looking at. One more, an AP-CBS telephone poll of 998 randomly selected Americans revealed 6 in 10 respondents believe that there has been progress in finding a cure for cancer in the last 30 years. So the population would be all Americans. The parameters of this population are the percent of these Americans who believe there is progress. The sample is 998 randomly selected Americans of the Americans surveyed that believe there is a progress on the cure. A representative sample is a sample in which the relevant characteristics of the sample is generally the same as the population. So it mimics the population. You're going to be asked questions about the type of sampling methods. So simple random sampling is we choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. Systematic sampling is a little different. So we use a simple system such as I'm going to pick the every 10th or 50th member. Convenience sampling is exactly what it sounds like. We choose, I got to work on my spelling, a sample that is convenient to select, such as people who happen to be in the same class. We're just picking them because it's just convenient. Another example might be the first 100 people that walk into a store. Stratified sampling involves groups, so subgroups. So we identify the subgroups and then draw a simple random sample from each subgroup. The total sample consists of all samples within. And these are some little examples too. So simple random sample. Computers can generate random numbers of telephones. Convenience, hey, do you support the death penalty? Just asking people who walk by. Stratified would be to take the population and then perform some surveys on the groups. And systematic is choosing based on a system. So identify the type of sampling used in each case and comment on if it's likely to be representative. That's the directions for the first few. The last few, we're just going to tell what kind of sampling is being used. So we have, you are conducting a survey of students in a dorm. You choose your sample by knocking on the door of every 10th room. So this would be systematic because we are choosing every certain amount of people, and that's every 10th in this case. And then we go and we then ask them about whatever the question is. And it is representative because these students would be randomly assigned. To survey opinions on a possible property tax increase, a research firm randomly draws the addresses of 150 homeowners from a public list of all homeowners. So this would be a simple random sample because we are choosing randomly from a list of homeowners, and it's not that we're drawing the first 10 or the first 20, it's all random, so everyone has an equal shot of being chosen. And it is representative because the list is primarily made of homeowners, so that sample will probably be representative of the population. Agricultural inspectors for Jefferson County check the levels of residue from 3 common pesticides. So this is that corn problem again. So this would be stratified because we have different pesticide use. So we're going to consider each farm as a subgroup of the population. So farm A, farm B, farm C, all the way for however many farms there are. And this is also going to be representative as long as the corn is collected randomly within each one of those farms, meaning each one has an equal chance. Last one involving that is anthropologists determine the average brain size of early Neanderthals in Europe by studying skulls found at 3 sites. So this would be convenience sampling, and that's because we are only looking within Southern Europe. We're not spreading ourselves out maybe across the world. And also you're only looking at 3 sites. Maybe if you looked at it more, then it would be a better sampling. Even though they have a little choice, since there's only a few skulls that are left, we can say that this is representative of the larger population. And 3 more, just noting what kind of sampling. So an IRS auditor randomly selects for audits 100 single taxpayers. So this would be stratified because each taxpayer is broken into whatever tax bracket. Every 100th cast iron pipe coming off an assembly line. So this is systematic because it's every certain amount. A taste test for chips and salsa at the entrance to the supermarket is convenience because you're just setting yourself up in front. What about people walking around? So that would be convenience. Representative sample. Collect raw data. Use the statistics to infer or make conclusions about parameters, and then draw conclusions. These are pretty self-explanatory, so read through them, and then if there are any questions, reach out to me. But basically these steps, so I'll kind of run through this first one. Each month, the U.S. Labor Department surveys 60,000 households to determine characteristics of the U.S. workforce. One population parameter of interest is the U.S. unemployment rate, defined as the percentage of people who are unemployed among those who are employed or actively seeking employment. Describe the steps that would be used. So, what's the goal? Well, the goal is to learn about unemployment or employment within the population of Americans who are currently employed or seeking employment. Step 2, choose a sample. So, the sample would be, in this case, 60,000 households within the entire United States to determine what people are employed or seeking employment from that sample. Step 3, collect raw data from the sample and summarize by finding sample statistics of interest. So the Labor Department would ask questions, and the responses would be the data. The department then uses the data into sample statistics, such as they'll maybe find the percent of people who are unemployed or employed. They'll use whatever statistics they feel is appropriate. Use the statistics to infer the population. So once these statistics are measured, they'll make estimates of the population based on the unemployment rate, and then they'll say, okay, well, that's probably the unemployment rate of the U.S. So that sample is going to relate to the employment or unemployment rate of the entire country. Draw conclusions. So the Labor Department draws conclusions based on the population parameters. For example, it might use the current job and past unemployment rates to draw conclusions about whether jobs have been created or lost. There's another example here. Okay, and one more. So read through them and then just email me if there are any questions. There are two types of studies. So there's what we call the observational. Basically, I like to think of this as what you see is what you get. So in an observational study, researchers observe or measure characteristics of the sample, but do not influence or modify the characteristics. In an experiment, researchers apply a treatment to some or all of the sample members and then observe the effects. A treatment group is the experiment is the group of members who receive a treatment. Now there could be multiple treatment groups. So maybe there's a new drug and or two new drugs, and they want to see if there's any effect. So they'll make a group A getting drug 1, a group B getting drug 2, and then we have a group 3, which is our control group. And a control group is the group of sample members who do not receive anything. They don't know, but I'll get into that in a moment. Placebo. So placebo lacks the active ingredients of a treatment. Members of the group don't necessarily know that they're receiving a treatment or not. So the placebo effect is where a person might think that they received the treatment, and so they go, oh wow, I have no more headache, when they really might have just received, let's say, that sugar pill. So that's called the placebo effect. Blinding. So a single blind in an experiment is where the participants do not know if they're part of the control or treatment group, whereas a double blind is where the experimenters know in the single, in the double, nobody knows anything. So whoever's measuring the statistics doesn't know who's in what group, and whoever is being given the experiment doesn't know if they're in the control or the treatment. Some common issues with experiments. So again, I wrote a lot of the answers here for you, but I'll go through them. A chiropractor performs adjustments on 25 patients with back pain. Afterward, 18 patients say they feel better. The chiropractor concludes the adjustments are an effective treatment. So if this is done on, let's say, so what could be a problem with this? So since I mixed these up, sorry guys, so this one should be up here and this one should be here. So I'll fix that, but this goes here and this one goes down there. I'll fix that in the posted lesson. But in any case, the 25 patients who receive adjustments represent a treatment group, but this study lacks a control. The patients may be feeling better because of a placebo effect rather than any real effect of the adjustment. So they could just say, oh wow, I got an adjustment, so I feel better. Not necessarily that the treatment is causing this effect. The chiropractor might improve the study by hiring an actor to do a fake adjustment, so one that feels like manipulation but doesn't, but actually isn't, on a control group. Then he can compare the results. And then B, a new drug for a type of attention disorder is supposed to make children less disruptive. Randomly selected children suffering from the disorder are divided into treatment and control groups. Those in the control group receive a placebo that looks just like the real drug. The experiment is single blind. So remember, single blind means that only the experimenters know which goes into each group. The people actually taking the drug don't. Experimenters interview the children individually to decide if they become more polite. So since the experimenters know which children receive the drug during the interviews, they may inadvertently speak differently to those children or interpret their behavior differently. The experiment should have been double-blind, where maybe the experimenters don't know which group they're in, and they wouldn't speak to them differently. They would just measure whatever they see. Okay, so in this problem, it says consider a medical study designed to test whether large doses of vitamin C prevent colds. To conduct the study, the researchers must ask some people in the sample to take large doses of vitamin C. This type of statistical study is called an experiment because some participants receive a treatment and that they would not otherwise receive. Okay? So it is difficult to determine whether an experiment, this is just reading now, whether an experimental treatment works unless you compare groups that receive the treatment to those who don't. In the vitamin C study, researchers might create two groups of people, a treatment group that takes vitamin C and a control that does not. The researchers can then look for differences in the number of colds. Having a control group is crucial. In an experiment, it is more important for the treatment and control groups to be alike in all respects except for the treatment. For example, if the treatment group consisted of active people with good diets and the control consisted of sedentary people with poor diets, we cannot attribute any differences in colds to vitamin C alone. To avoid this, assignments to the control must be done randomly, and that's the idea of taking bias out of the picture. We'll discuss that more going forward, but that is very important to take note of. Determine which of the following studies is observational or an experiment, and if so, let's make sure that we also identify the control and the treatment groups. So which of 8 airlines has the highest customer satisfaction? That would be an observational study because you are just going to merely survey who likes what airline based on an observation. How do teachers' salaries compare to college professors' salaries? Again, you can't change their salaries, you merely can report on them. So again, the best thing to do would be to say that that's observational. Is deep massage effective at relieving lower back pain? So that would be experimental, with a control group receiving no massage with lower back pain and a treatment group of people with lower back pain receiving deep tissue massage. Surveys and opinion polls. So this has to do with what we call the margin of error. And surveys and opinion polls are observational studies and are among the most common types of statistical study. You'll hear a lot of this with the upcoming election. Suppose a poll finds 46% of public supports the president with a margin of error 3 percentage points. 46% is called your sample statistic, meaning error helps us understand how well the statistic is likely to approximate the true population parameter. That should say parameter. Again, I'll fix that. By adding, so that would be all Americans who support the president. In order to add and subtract the margin of error, we find what we call the confidence interval. And this is representative of us being 95% confident. So for example, 46 minus 3 would be 43%. 46 plus 3 would be 49%. So we are 95% confident that the confidence interval will be between 43 and 49%, and that would be representative of what we think the population would say. So here's an example. An election eve poll finds 52% of surveyed voters plan to vote for Smith, and she needs a majority, more than 50%, to win without a runoff. The margin of error in the poll is 3 percentage points. So to find the confidence interval, 52 minus 3 and 52 plus 3 gives us an interval of 49 to 55%. We can be 95% confident the actual percentage of people planning to vote for her would be between this number. Since the interval leaves us with a majority, so a majority would be more than 50%, or less than a majority, so that would be either a split, 50-50, or 49%, we cannot say that the election is going to be all hers. It's too close to call. Here are a couple more examples. So a poll conducted the day before the student body presidential election at a Midwestern university showed that 52.8% favored Mario, the rest favoring Ying Lang. The margin of error is 30.6%. Should she have conceded? So conceded basically means, or he, that you are going to leave the election because you're not going to win it. So here is your interval. Okay, we can be 95% certain that the actual percentage of people voting for Mario is between this number. The interval does contain the majority, but I also want to add in here that it's pretty close. So we might want to say that it is too close to call, and so that he cannot concede. But in this case, the majority really is in there, so we can say, I guess it's based on preference for that one, but I would say it's too close. Following the Republican National Convention, a poll of votes in central Illinois, communities showed that 57% would vote Republican over Democrat. The margin of error is 4.8, so here is your interval. Should the Democrats expect to lose? So remember, this is going to be that we are 95% confident the actual percentage of people who would choose the Republican ticket to win is between here. Since this is definitely a majority, the Democrats should expect to lose. These are a little tougher, but I do like them, so let's go through them. The day before the election, 53% favor the Green Party candidate with the margin of error given. So here is our confidence interval, and because this confidence interval contains the majority, we can say that the Green Party should plan a victory. They probably will win. In a survey of 1,002 people, 701 of them say they voted in the last presidential election. So that's about 70% of the people. Actual voting records show that 61% of all eligible voters voted. Okay, so we have to be careful because the actual number of people that vote, and I got to fix this too, so it's going to be 70% of the people minus 3% is 67%, and 70% of the people plus 3% is 73%. So I'll fix this in the notes, but this should be the interval. 61% does not fall in this interval, which was the actual number of people. So they did lie because more percentage of questions.